Hello everyone, welcome to One Stop Electronics. This question is from ISRO examination. The question is, find the transient response of a pair of complex poles as given below. This is the diagram given and these are the four options. We have to calculate the transient response due to these complex poles. So let's see the answer. This is the real axis and this is the imaginary axis. The location of this pole is minus sigma plus j omega. The location of this pole is minus sigma minus j omega. So the poles are minus sigma plus minus j omega. We can see that the real part of the pole is lying in the left half of the S-plane. So the real pole which is lying on the left half of the S-plane will generate a response that is exponentially decaying component. So the response generated due to a real pole lying in the left half of S-plane is exponentially decaying component. If the pole is located on the right half of the S-plane, if the real pole is located in the right half of the S-plane, then it will generate a response that is increasing exponential component. But here we are given the poles which are lying in the left half. So the real part is lying in the left half. So we can say that the response will be an exponentially decaying component. In this complex pole, we can see that the imaginary poles, now we'll see the response generated due to the imaginary pole pairs. So the imaginary pole pair will generate a response which is oscillating component with the constant amplitude. So the response generated due to imaginary poles is oscillating function with a constant amplitude. So the combined response will be the combined response of this pole will be the combination of two, means it will be a component which is a decaying sinusoid. So this will be the response generated due to this complex conjugate poles. So it resembles option A. So A is the correct answer. We can see the explanation as the complex conjugate poles generate a response that is decaying sinusoid of the form A e raised to power minus sigma t sin omega t plus phi, where this sigma specifies the rate of decay and omega specifies the frequency of oscillations. So the correct answer is option A. Thank you.